Welcome. Today we're going to talk about solving multi-step equations, Part 2, consecutive numbers. Well, consecutive means in a row. Consecutive days could be Wednesday, Thursday, Friday. Consecutive months, June, July, and August spring to mind. So when we talk about consecutive numbers, we're looking for numbers that are in order, in a row. Here's the definition. Let's write this Cornell style. When you count by ones from any integer, you are counting consecutive integers. You need a question to which this is the answer. How about, what are consecutive integers? Here's an example. Two consecutive integers are 120 and 121. Three consecutive integers, for example, -5, -4, and -3. Typically, these problems come up as word problems, so we're going to do 3 examples. The sum of two consecutive integers is 41. Find the integers. Well, in this case, first of all, we wanted to find the first integer. So we're going to let n equal the first integer. And usually for students, the hardest part is figuring out how are we going to represent the second consecutive integer. I'd like you to think about that for a moment. How could you represent the integer that comes after n? And we're going to represent the second integer with n plus 1. Because if n is one number, then the next number after that would be n plus 1. Makes sense to me. If n equals 5, the next number would be 5 plus 1 or 6. If n equaled 19, the next number would be 19 plus 1 or 20, and so on. Okay? So now the sum of those two numbers is 41, is meaning equals. So we have the sum is when you add two numbers together. N plus 1 equals 41. I'm going to continue this problem on my next page, but n plus 1 equals 41. Now, this is going to be multi-step, but fairly simple. We can use our associative property to regroup the two n's together. N plus n equals 2n. And the 1 is not like those. We're going to have 2n plus 1 equals 41. And we'll put the line of equality, box out 2n. I like to do that because in a two-step equation, first I solve for the term that has the variable, and then I isolate the variable. Okay, so step 1, add or subtract. We'll subtract 1 from each side, and we get that 2n equals 40. Step 2, multiply or divide. Let's divide by 2, and we get that 2 cancels 2, and we have n equals 20. Is that the answer to the problem? Partially. Let's go back to the question. The question said two consecutive integers add up to 41. Find the integers. So n equals 20. That's not two consecutive integers, that's only one. We also want n plus 1. And together, they should add up to 41. So that checks out. N plus 1 equals 41. All right, next example. The sum of three consecutive integers is 96. Find the integers. I'd like you to try this one on your own and then check back and see if you were able to solve it. Okay, once again, we're going to let n equal the smallest integer, and the second consecutive integer would be n plus 1, and then the third integer would be n plus 2. So in our equation, we're going to add those three things together. N plus 1 plus n plus 2 equals 96. That's the sum of three consecutive integers. To solve this one, once again, we can use our commutative and associative properties to group the n's together. N plus n plus n, this time equals 3n, and 1 plus 2 equals 3. So we have 3n plus 3 equals 96, which is now a two-step equation. So step 1, let's subtract 3 from both sides, and we get 3n equals 93. And step 2, divide by 3, and we get n equals 31. Once again, 31 is only a single integer, and our question was asking for the 3 consecutive integers that add up to 96. So that would be 31 and 32 and 33. Those are the 3 consecutive integers, and once again they do add up to 96, so that checks out. One more type of question might ask about consecutive odd integers or consecutive even integers. In a case like this, we still would represent the first integer with n. Okay, this one says the sum of 2 consecutive odd integers is 36, and find the integers. Well, if the first integer is n, what would the next odd number be? And if you think about it, after 1, the next odd integer would be 3, and then 5, and then 7, and 9, and 11. So we're counting every other number. So after n, the next odd integer would be n plus 2. So the sum of n and n plus 2 is 36. Once again, we have a multi-step equation, which we begin by using our associative property to group the n's together. N plus n is 2n, and 2 is unlike. So we have 2n plus 2 equals 36. In a two-step equation, step 1, add or subtract. Again, we'll subtract 2 on both sides to get 2n equals 34. And finally, divide by 2, and we get n equals 17. And once again, this is one of the 2 numbers. So we want 2 consecutive odd integers that add up to 36. If the first one is 17, then the next one is 19. And together, they do add to 36. So that checks out. Thank you for your attention. Have a great day.